Okay, so we're recording. Let's go grab, let's see, I do not need to use that anymore. Let me grab, okay. Let's look at what the plan is. And every morning we'll start with looking at this and just me telling you what the plan is. Okay, so this is week 2. You can see here. Proctorio practice deadline is February 5th. That's Friday, a week, 2 weeks from now. It's not this coming Friday, it's the next Friday. So this week, what I want you to do is get ready for that. This is a practice 3-question test. I don't care if you miss all 3 of them. The grade does not count for or against
Okay.
you. It's just to give you a chance to practice for Proctorio so that you'll be ready when it really counts, when I will take off points and you won't miss points because you'll be on top of it. The way to get ready for that is to go to slide 3, the first slide, the lowest slide, the first one I gave you. This bottom row has 3 Proctorio sets of information. This first one, the Proctorio room scan, is 3 minutes. It's Ms. Campbell showing you how to do a room scan. Take 3 minutes of your time to look through that. My biggest, fattest problem that I have with students is that they don't show their scratch paper to me properly. So pay a special attention to the way she shows her scratch paper. And we'll talk about it on Wednesday more. The second box here, Proctorio instructions, is how to get Proctorio on your computer. There's simple instructions. You got to go through Google Chrome and then you go to attach to Proctorio. It's very simple. And then the last one, the Word document, is how, if you don't do this right, I take away your firstborn child, basically. So read those. That's how you're going to lose points. We'll talk more about it on Wednesday. But I do want you to have at least done these first 2 things. Look at the 3-minute Ms. Campbell's video on how to do a proper room scan and get Proctorio attached to your computer. I know from last semester some students were concerned about Proctorio spying on them. If that's a concern of yours, disconnect Proctorio between test times and reconnect for the test. I'm not sure that's completely valid, and the students that were concerned about it weren't sure either. But if that is a concern of yours, disconnect between tests. Okay, let's go back up here. So that's Proctorio practice. Watch Ms. Campbell's video, get Proctorio attached by Wednesday. Number 2, I don't think I stressed this enough, and I want to be sure that you know it. Each Perfect My Math Lab section is +1 bonus point on your test. So this time you've got, I think, let's see, 1, 2, 3, 4, 5, 6, 7 sections plus the review. So that'll be 8 points. I think 7 or 8 points. I'll count it up and get it right before February 12th. It's not an all or nothing thing, but each section that you have at 100%, I will give you 1 bonus point on your test. So each test you'll be able to make 7, 10, 11 points extra on your test. That's a huge deal. Number 3, if you still need to chat with me, and let's see, let me go over here and see if any of you guys are here. I don't think so. I think everybody, I've only got 6 out still, only 6. I've met with 34 of you. Thank you for spending your time with me. I appreciate that. I got video, it's a video and audio check prior to Proctorio, so it's the baby step leading into you guys taking your first test. Plus, it was nice to get to know you a little bit. And then this last thing, the 2.1 worksheet. It's not on the calendar. It's for next Monday, but we may get to it this week. So I've got a link to it for you. If you want to print it out, print it out. If you just don't have access to a printer or don't feel like going to Staples or whatever, it's okay. You'll pull it up for when we work on it on Wednesday, or you can just watch mine. I mean, you'll have to figure out what you're going to do. This class is not loaded with worksheets, but there are several of them. So you figure out what works for you best. But we may get to this on Wednesday. Okay, out here in the purple banner. on Wednesday from 12 to 1:30. There is somebody that TCC is sponsoring or going to, or some arrangement. If you're a government nerd, you might enjoy that discussion. The dude that's doing the discussion, let's see, it's a link to it, and I won't carry you over with me, but Dr. Thomas Patterson, he is at Harvard. He's a Bradley Professor of Government and the Press at Harvard University Kennedy School of Government and the Press. So if you're interested in something like that, in a discussion of presidential transfer of power, it's there for you. If not, ignore it, no big deal. And then in here, I've got just some things that I was excited about that I thought I'd share. Number one is Lady Gaga singing the Star Spangled Banner last Wednesday. Number two is Lester Holt interviewing Amanda Gorman. She's the young lady who recited her poem at the inauguration. She talks in there, some of it is her poem, some of it is her struggle with speech, some speech problems she had. It's a good interview. She's a cool chick. And number three, this is Whitney Houston singing the Star Spangled Banner at the Super Bowl in 1991. If you have not seen this, you just have to see this. It's as exciting as Lady Gaga's. Okay, questions about mostly this column of things that we're doing in class. Anybody, anything? No questions from Chloe. She speaks for the group, and so does Ashish. Okay, let's get going then. Good deal, good deal. Let me share my dot cam. Okay, so today we are finishing up 1.5, which should be somewhat of a review, somewhat of a dusting off, and then we're going to get into 1.6, other kinds of equations besides ones that we do factoring, doing zero factor property. You should have experience with these in a perfect world. If you don't, you don't, and we'll catch you back up. So we'll do what we need to do here to figure this out. Okay, let me first get a photo shot of who is here for attendance. I'll do it a couple of times during the hour and a half we have. Okie doke, we have already done zero factor property. That's probably what you call factoring, two sets of parentheses equal to zero, that kind of thing. Then we did 3 square root property problems. That's where you might have x squared equals 16, something like that. And then we would put the radical on both sides, that sort of thing. Now we're going to look at what's called completing the square. Completing the square. It's probably the most weird one of the 4 methods we're going to look at. Let's see, we're on section 1.5, and we've already done 1 through 4. That was last week. So we're picking this up. This will begin number 5, where they're asking you to complete the square. Let's look at how those are going to look. Let's first get ourselves ready for it. We're not going to do the whole thing this first time. Let's just get our feet wet, just sort of start this out. So if you have a problem that looks like x squared plus 4x, and you would have an equal sign back here, we want to change this into a perfect square by adding something here. So what we'll do is we want this to be a perfect square. That's a perfect square when we've got a binomial squared. This, if we FOIL it, would turn into this. So this is what you would be given, and you're asked to come up with this piece, the constant that you're going to add in there. So right now we're not going to do so much of the completion of it. We're just working with what would you add to this side to complete the square. And the way to figure that out is really easy. It's b over 2. b is the number that sits in front of the x term. So b is a 4. Divide it by 2, and we'll get 2. So what we're going to do, and then we're going to square that. That'll be our second step. We're going to do several of these. So we'll be adding in 4 right here. So the first question asks you only, what would you be adding in here? What you want to do is you want to take b and cut it in half and then square it. So b divided by 2 squared. Okay, let's do that a couple more times just for practice. Let's say that you had x squared plus 10x, something like that. And you're asked to come up with, what are you putting over here? What are you going to add to both sides? We'll eventually add it to both sides, but right now we're just worried about coming up with b divided by 2 squared. So take 10, divide it by 2, that'll give you a 5, and then square that. So we're going to add 25. That's the first couple of problems. They're going to ask you to come up with what goes here. Okay, let's do it with an odd number. Let's say we've got x squared minus 25x. Now we're not completing the square yet. We're not doing the works. We're just doing the baby step that will, the weird thing that will get us halfway toward completing the square. We're just figuring out what goes in this spot right here. So you would expect to see an equal sign back here, and we're trying to put in a spot right here. We're trying to put the constant number in there. So we have an x squared, an x term, and a number. Same thing we were doing here, b over 2 and squared to determine what goes there. So let's take negative 25, be sure you see it's negative 25, divided by 2. Don't change that to negative 12.5. It works better when you don't, and why make more work for yourself? So first thing we do is take b over 2, and now we're going to square it. So you want negative 25 squared. Be careful anytime you're squaring a negative. A negative squared will be a positive number, but if you put it in your calculator, let me see if I can get rid of some of that shine for you. If you put it in your calculator, negative 25, and then you do the humpy key squared, it's going to give you negative 625 because you didn't ask it right. You asked it only to square the 25, so you've got to put this in parentheses. So parenthesis, negative 25, close the parenthesis, and then humpy 2, then caret 2, square it. And that gives you a positive 625, because you know that a negative squared ends up being a positive. So we get 625, 2 squared is 4. So 625 over 4 is the thing that we're going to be adding there. Let's see. Okay, that's enough playing around. Let's get serious on this one. Let's do one of these. We're only doing one completing the square in the works. We're only doing one completely because this isn't that important. We're not going to, I don't think we ever do it again. I won't give it to you on a test, so therefore it won't be on our review. It's just to round you out in all of the 4 different ways we have of doing quadratics, zero, square root property, and this is completing the square. So let's do this entire problem. Let's say we had x squared plus 6x minus 16 equals 0. New problem, and we'll do the whole works on this. The first thing you've got to do in one of these problems is get it just x squared and 6x. Like this was x squared and 4x, x squared and 10x, x squared and negative 25x. So move that 16 to the other side, equals a positive 16. When he moves across the equal sign, he turns to his opposite, or you can add 16 on both sides. It's the same action. Okay, now let's do this baby step, this blue step that we've been doing, the b divided by 2 squared. So we're going to take 6, divide it by 2, and square it. So 6 divided by 2 is 3, and 3 squared is 9. So plus 9 there. And the fact of the matter is that if you add 9 to one side of an equation, it's a teeter-totter, it's a seesaw. you have to also add 9 to that side. That's how that goes. Okay, this now, with adding 9, have completed this square. This is a perfect square. We can factor this down here. What will go in the first spot? X. The signs need to be the same, and then, and what's the square root of 9? That's a 3. Well, it's x plus 3 times x plus 3 will give you x squared plus 6x plus 9. So when we complete the square here, we know we're going to get a binomial times itself. I mean, if we had done this zero factor property, we would have set up 2 sets of parentheses, put x's, signs need to be the same and they need to be positive. What times itself will give you 9, or what times what will give you 9, that multiplies to give you 9 and adds together to give you 6. And then we've got this. This is what you want to do. You want to be fancy pants and make it this way. I'll show you why in a second. Yes, Kaylina.
Whenever you started the x squared plus 6x minus 16, did you start a new problem? I just want to make sure.
Yes, that's why I drew this little squiggly line that tells you it's a new problem coming up.
Mm-hmm. And for the negative 16, was that like what the problem was before you moved it over, and then you had to refine the last number for the completing the square?
Yes, the first thing you'll do in completing the square is make sure that the constant is over on the right-hand side. That's your first job. These that we did that were the baby ones didn't have a third number, so we didn't have to send it to the other side. They just gave us the x squared and the x. But if you've got the x squared and the x and the constant, you need to first get him shoved over to the right-hand side. Is that your question?
Yes. Thank you.
Cool. You're welcome. Okay, so 16 plus 9 is 25. And now here we sit at a square root problem. We have a perfect square here, and we have a perfect square here. So this is just exactly like what we did on we did 3 square root problems on Wednesday. This is the third of them. So let's take the square root of the left-hand side. Squaring and unsquaring cancel each other out, so we have x plus 3. If you take the square root of one side, you have to take the square root of both sides. You put the radical on, so it's not good enough to say square root of 25 is 5. You have to also consider that the square root of 25 is negative 5, because positive 5 times positive 5 will give you 25, but negative 5 times negative 5 will give you 25 also. And then just like the third problem we did, like number 4, in 1.5, now we're ready to set x by itself by moving the 3 over. So minus 3 on both sides, and we get negative 3 plus or minus 5. You're not allowed to leave this alone because these are like terms, so we can combine them. So let's separate it out into negative 3 plus 5 and negative 3 minus 5. So x equals 2. And x equals negative 8. And those are the two answers that would work in this problem, x squared plus 6x minus 16. Now, the fact that I got normal numbers, that I got rational real numbers, I know exactly where they are on the number line, tells me I could have taken this original problem and factored it into 2 sets of parentheses the old-fashioned way with zero factor property. Let's look at that. Signs need to be different. What 2 numbers multiply to give me 16, whose difference is 6? That'll be 2 and 8. 8 is the larger number. I'm always going to pair the larger number with the first sign when the signs are different. So an 8 goes there and 2 goes there. Set them each equal to 0. So x equals 2. And x equals negative 8, which has to be the same answer as we got when we did it a different method. So this method is more cumbersome. It's not as familiar to you. You'll have you'll have a couple problems like this where you just have to come up with the constant that gets added. And then you'll have one problem where you're going to have to do the works. Just use this as a model to get that one right, or use the, pull up, view an example. You won't have this on a test. You won't have completing the square on a test. I'm something's niggling at my brain right now, and I'm thinking that we will have this blue piece as a question on their final, I think. But let's worry about that in May. And anyway, when you do this homework, that's such a tiny piece of it, is b divided by 2 squared, and plop it in there. So if we have to worry about it in May, we'll worry about it in May. Okay, let's move forward to your fourth method. You come back up. You got zero factor property. You've got square root property. You've got completing the square. That is kind of weird. I get that. That might not be convenient for you. It might not be useful. I'm not sure there's ever a time when I would go to that method. And then we've got quadratic formula. Quadratic formula is the last of the methods that you need to worry about. And we'll use all 3 of them randomly in this class. It is a formula, and you'll have to memorize it. It will not, am I lying to you right now? Let me think. No, I think you need to know it, because we're going to use it in so many different ways. So I do require that you memorize it. Write it down fresh every time you use quadratic formula, and your brain will take care of that for you. You won't have to memorize it. It won't be a task. Your brain will memorize it. So x equals, which is what we want to do, got a fraction bar, negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the formula. If you would like to, go to YouTube and you can learn how to sing it. If you would like to, there's a Britney Spears tune that it's sung to. Pop Goes the Weasel, you may have learned already. If anybody feels like singing it, well, join in anytime. Okay, let's use quadratic formula. X squared plus 9x plus 11 equals 0. This is not factorable using zero factor property. It's not factorable using square root property because we've got this x. With square root property, you want an x squared and a number only. So we're going to have to use the quadratic formula. And the quadratic formula, BTW, is always the method you can use. I've had students before in college algebra who don't want to use zero factor property, 2 sets of parentheses. They just want to use quadratic formula. They're used to it. They're quick with it. We'll use this a lot. You'll get better and better. You're forced to use it anytime the answer is not rational numbers. If you're going to get a square root answer for a root, if you're going to get an imaginary number, you're going to have to use quadratic formula. It won't factor any other way. So let's practice that. A is always going to be the number in front of the x squared. So in this case, it's a 1. B is always going to be the number in front of x. So in this case, B is a 9. And C is always going to be the constant. So in this case, C is 11. So if you like to build this chart, feel free. Otherwise, you can read it right off of the problem. So first, set it equal to 0. We've got everybody piled on the left-hand side. I've written my A and my B and my C. Let's find the roots. X equals, it says a negative sign, so let's put a negative sign. Then B is 9. Then plus or minus, that's going to give us our 2 roots because we know we need 2 roots. So something plus this blob, and then something minus this blob. That's what gives us the 2 answers that we need. So plus or minus, and then the square root of B, that's 9 squared, minus 4 times A is a 1, and C is 11. And then before I go down to the bottom, I'm going to look here. The biggest mistake I see students make is that they don't get this sign right. So take a second right now. Let me start with this. 9 squared, if it were a negative, it's still, when we square it, will be a positive. So this leading number under the radical will always be positive. Now let's go look back here. This is a negative times a positive times a positive. So that's going to stay negative. I'm not worried about changing the sign. So I'm going to leave it as a subtraction problem under that radical, divided by 2 times a, and a is a 1. Once you get those in place, this is just a matter of cleanup. Let's see, so x equals -9 plus or minus 9 squared is 81, -4 times 1 is -4, and then that -4 times 11 is a -44, 2 times 1 is a 2. So 81 minus 44 is going to be 37, I believe. I'm not going to do public math every time. So 81 minus 44, 37. So we've got, our answer is -9 plus or minus the square root of 37 over 2. Now we need to see if we can go further. Let's look at -9 is a rational number. That's a normal number. We can deal with that. Square root of 37 is a radical. That's not a perfect number. If it was square root of 36, yay, 36 is a perfect number. We'd go to town on that. But it's not. We're at a dead end here. This is our answer. If you wanted to write it more clearly as being 2 answers, you could write x equals -9 plus the square root of 37 over 2, comma, -9 minus the square root of 37 over 2. That's what it means, that plus or minus key. It means we have one version plus and one version minus. You can write either of these in MyMathLab. They'll accept you writing it twice. They'll accept you using the plus or minus key. MyMathLab used to not always be that way. They used to require, they didn't have a plus minus key. They used to require that you wrote it separately. And I actually kind of prefer that because then it is so obvious to you that there are 2 different answers. This brain sort of says, well, there's one answer, when in fact there are 2. But you can write it either way. That's the only quadratic formula we're going to look at in this section. That's not completely true. That's the only one we're going to look at right at this instant. How about? But what we want to look at before we move on from here is the discriminant. The discriminant is that number right there. 37 is the discriminant. What the discriminant tells us is so much about this problem. If we only look at the discriminant, we can tell a couple of things about it. First off, we know we've got a plus or minus in front of it. So we know we're going to get 2 answers. That's big. We know we're going to get 2 answers here. The other thing we know is that it is not perfect, that it is going to be it's going to be an irrational number, However, whether it was 36 or 37, it's still going to give us real numbers. This we can look at. This is a real number. The square root of 37 is a little bit bigger than 6, teeny weeny bit bigger than 6. It exists. You can look it up on your calculator. You can go square root of 37, and there you go, 6 and a little bitty bit. So it exists in the real world. So we know we're going to get 2 answers, and they'll both be what MyMathLab calls unequal real solutions. I'll put these kind of things out in a little chart for you in just a second, so you don't need to be developing anything, just kind of listen. The 37, because the square root of 37 is a real answer, we know we're going to get 2 answers here. Now, this piece of information about the discriminant, that's just the number under here, doesn't tell us what the answers are. We had to do all this crap to find the answers. But if we only wanted to know, so what kind of answers are we going to come up with? We would know we'd get 2 because it says plus or minus. And we'd know they'd be unequal to each other because a positive square root of 37 is different from a negative square root of 37. This is a positive 6 point and a little bit. This is a negative 6 point and a little bit. But they are real. So oftentimes we only want to know what kind of answers are you going to get when you do this, when you try to factor this equation. We're not interested in specifics. We're just interested in how many and what kind of answers are we going to get. We're going to use that extensively later on in this class. We don't want to know exactly where they are. We just want to know what kind of answers they are. So in order to know how many answers we're going to get and what they're going to be looking like, we only need to inspect the discriminant, only need to look at that number under there. And that's because this will always be a rational number. This is just B. This is just what sits there with a negative sign in front of him. And down here in the denominator, that's always going to be real and rational and normal to us, where we can find it on the number line real easily. So these guys are not our concern. This is our concern. How weird does this get? So let's explore just the discriminant. You're going to be asked to do that a couple of times on your homework, to look at the discriminant and just decide how many. Let's see, we need to know what is the discriminant first, what is it, and then the number and type of solutions we will get. So there are a couple of questions they'll be asking you. So in this case, the previous problem, the discriminant is 37. How many answers? 2, because we've got a plus or minus here. And then what type? They're unequal real solutions. So let's go through and look at a couple of those. So we know now, let's see, let me put these right up here. If we get something like the square root of 37, for instance, then we know we're going to have 2 unequal real solutions. There are 2 of them, a plus and minus, and they're going to be unequal to each other because a positive square root of 6, a square root of 37 is different from a negative square root of 37. Okay, let's play around and see what else we can find out. Let's look at, say, 3x squared minus 4x plus 2 equals 0. Let's say that's the problem we were handed, and we're trying to find not the answers, not where this is going to cross the x-axis, not where the x's are, not where the roots are. That's all the same way of saying solve this. But if we're asked only to find the discriminant and the number and type of solutions, that means all we've got to look at is that piece, the b squared minus 4ac piece, the part that's under the radical, the part that can go crazy on us. Because on the quadratic formula, the negative b is not going to go crazy and the 2a is not going to go crazy. But this thing, as we found out, could be a 37, and that's not pretty. Oh, I think I think you got it in the picture. So this will be normal, this will be normal. This is where the weird stuff happens, and that's called the discriminant. So let's look only at that piece. If you're a person who likes to write a chart, you go ahead and do it. A is 3. B is negative 4. And C is 2. So there's our chart, if you like to develop that. Let's see. So B is a negative 4 squared minus 4. A is a 3. And C is a 2. So negative 4 times negative 4 is 16. This is a negative times a positive times a positive. So I'm going to have a negative there. 4 times 3 is 12, and 12 times 2 is 24. 16 minus 24 is a negative 8. Boy, that's as weird as a discriminant can get. So when they ask you what is the discriminant, your answer is negative 8. Not all this folderol around it. That's just to remind us of a couple of things. But the discriminant is a negative 8. Now the number of answers we'll have are 2. There's a plus and a minus. And then the type that we have, oh my goodness, this is an imaginary solution. There's no such thing as a square root of negative 8. Try it on your calculator. Got the square root of negative 8 Domain error, can't do it. Remember, that's where we use I, our little imaginary friend I, square root of -1. So the type here that you will be matching, you'll be dropping down to this, is imaginary solutions. So the answer for the discriminant would be -8 in this problem. The number, they have 2 of them, and they are imaginary solutions. So let's add to this little chart. If you get a negative number under there, then the discriminant is just the -8. They don't want all the decoration around it. They just want -8. And the number of them, you've got 2 of them, a plus version and a minus version. And the type is imaginary solutions. So you'll be matching on MyMathLab to 2 imaginary solutions after you put in the discriminant of a -8. Let's do another one. Let's look at x squared minus 44x plus 484 equals 0. That's x squared minus 44x plus 484 equals 0. X equals, nope, we're not doing the whole folderol. This is only under what is the discriminant and how many and what type of solutions would we expect. So all we're interested in is the discriminant, plus or minus b squared minus 4ac. That's the only piece we're concerned about. So plus or minus, oh, let's see, if you write a little chart there, if you'd like a chart, A is 1, B is -44, and C is 484. So B is -44, and I need to square all of it. That's going to end up with a positive number, of course. And then minus 4 times A is a 1 times C is 484. Okay, let's use our calculators to square -44. Because you know a negative squared is going to give you a positive number, you don't need to put in a negative there if you don't want to. You can just do 44 times 44. That's certainly giving you 44 squared. 1936 there. And then I've got a negative times a positive times a positive. So that'll be a negative in the verb there, in the joining of them. And then let's do -4, or we've already taken care of the negative. So 4 times 1 times 484 gives us 1936. So we get plus or minus 1936 minus 1936 is 0. So the discriminant here, when they're asking you for the discriminant, that's 0. The number of solutions we're going to have, though, is not 2. It looks kind of like it's going to be 2 because you've got a plus and a minus there, and that certainly is 2 of them. But what is the square root of 0? Square root of 0 is just a 0. Positive 0 minus 0, that's the same thing. So you're only going to have 1 answer in this particular problem. Instead of having 2, you're going to have only 1. And the type that is just a real solution. So you'll be matching to 1 real solution. Let's go back up here and add that one to our little chart. When you get a 0 for a discriminant, then the number that you will have of solutions is 1, and it will be a real solution. Adding 0, subtracting 0, you get the same thing. Will 0 be the only time you have 1 solution? Yes, sir, it will be. That's the only time when you've got a 0 under here, it's going to be a 1. So we're done with this chart. This is all the possibilities that can happen to you. I would start down here. If it's a 0, you have 1 real solution. And remember all this decoration here. This is for the quadratic formula. There we go. for the quadratic formula right here. If this becomes a 0, then all you have is negative b over 2a, one answer. You won't have plus 0 and minus 0. So that's why you only get one answer, negative b over 2a. This piece goes away. So if you get a 0 under here, the discriminant is a 0, and we'll have one real solution. If you get a negative number under there, you're going to get two pieces of crap, two unuseful numbers to you. I'll show you what that looks like really soon. Next week we'll look at that because we'll end up with a parabola that won't cross the x-axis. And then this, and we'll worry on that next week. And then if you get anything else other than a 0 or a negative number, if you get any number, you're going to end up with two answers, and they will be not equal to each other, and they will be real. So we'll be able to find these on the number line. We can find 0 on the number line. This we cannot find. So these, with a negative, you'll get two imaginaries. With a 0, you'll get one real. Anything else, you get two real solutions, unequal real solutions. So these are the choices that you will see at my math lab. Okay, let's play around a little bit with just solving some of these things. Let me give you a new problem, fresh problem. We've got 7x plus 4 times x plus 1 equals 1. The instructions here will be solve. You know that's going to be solved because you've got an x and an equal sign. So you're going to have to take it all the way down to x equals 2. Okay, look at what we'll need to do here first. Let's see. We've got a binomial times a binomial. I'm thinking we got to FOIL this. So let's FOIL it out. 7x times x is 7x squared. Do the outside. That'll give you a 7x. Do the inside. That'll be a 4x. And multiply the last. That's 4 times 1. Don't forget it's equal 1. Don't lose that. Next, and I'm pausing here to give you time to breathe, but also to give you time, those of you who are comfortable with the next step, to go ahead and take the next step. So I want to combine like terms in here. So I have 7x squared, and then I've got 7x and 4x. They both have an x on them. So 7, 8, 9, 10, 11. I've got 11x. Okay, now we have very strong looking quadratic problem. And if you're going to do zero factor property or you're going to do quadratic formula, you need to get a 0 over here. So the first thing we've got to do is move the 1 over. You can go straight into quadratic formula if you want to. You might not be as comfortable with that, so you might be more comfortable just seeing, can I do this with zero factor property? So let me see. Is there GCF? Nope, those are all prime numbers. 7x and x is going to get me 7x squared. I see I've got a plus sign back here, and remember when you've got a plus sign at the back, that means these signs need to match. They'll both need to be pluses, or they'll both need to be minuses. All we've got in this problem is pluses, so let's put pluses in here. And then the only way to get to 3 is 3 times 1. If I put, let me use a pencil here. If I put a 3 there and a 1 there, then I've got an outside 21x. Oh my gosh, I'm just trying to get to 11. So that's not going to cut it. Let me swap those two numbers out and put the 1 here and the 3 there. I've got an outside 7x and an inside 3x. That gives me 10x. I need 11x. That's not good. This is not factorable using zero factor property, using the old-fashioned method, the one you're probably most comfortable with. There's no way we can get 11x out of this. The only way to make 7 is 7 times 1. The only way to make 3 is 3 times 1, and we tried both ways, and we were unable to get 11x out of that. So this is not going to work for us, so let's go use quadratic formula. This is where you write down the quadratic formula, copy it down if you need to, or do it from memory, but this is where your brain starts working on memorizing it when you write it. So we've got negative b plus or minus the square root of b squared minus 4ac all over 2a. If you want a little chart, a is a 7, b is 11, and c is 3. Okay, so it starts with a negative sign, put a negative sign there, and then grab b. And then b squared minus 4. I sure wish we'd have a negative in here. Yeah, we will in the next problem. Cool. Okay. Negative 4 times a times c. And before you go downstairs, check out this and make sure if you need to ultimately be subtracting or if we need to change this to an addition sign. Negative times a positive, we're good. We'll be subtracting in there. Okay, on bottom you've got 2 times a, so that's just going to be a 14. Okay, once everything is in place, especially that sign, you're good to go. Negative 11 plus or minus 11 squared is 121. Negative 4 times 7 is negative 20. It's easier for me. Negative 4 times 3 is negative 12. And 12 times 7 is 84. And that's going to be with a negative. Over 14. Okay, let's keep working this problem down until we can't do anything more with it. 121 minus 84. 37 seems to be rather famous around here in these problems. And we're done. There isn't anything more you can do to this problem. Square root of 37 is not perfect. If he were 25 or 36 or 49, we'd continue forward. But he's just a dud. There's nothing coming out of 37 that's perfect. So this is our answer right here. Negative 11 plus or minus the square root of 37 all over 14. That is 2 answers. It's negative 11 plus about 6 divided by 14 and negative 11 minus about 6 divided by 14. But we're not going to have to take it further. Rarely in this class are we going to find a rounded number, the equivalent of the square root of 37. We'll just leave him alone. Okay, let's do another one like that. Let's look at 5x minus 2 squared divided by 4. Write that for you. 5x minus 2 squared equals 4. We don't need to use quadratic formula for this one because this is a perfect square. So let's go do square root property. Let's practice that one a little bit. So this is a perfect square, and we don't care about this, but this is the one that we really have to worry about. We have to be able to unsquare that. Just like number 4 on this section before, we've got a perfect square squared. So let's take the square root of that. You know that squaring and unsquaring completely cancel each other out. So on the left-hand side, we get 5x minus 2. Whatever we do to one side, we have to do to both sides. So we've got an equal sign. Square root of 4 is 2, but remember, you put the radical on. So you have to consider both the positive and the negative versions there. Otherwise, we're not going to get our 2 answers, and I can tell we need 2 answers. Exponent will always tell you how many answers you're going to get. Okay, now we need to get to x equals. So the first thing we want to do, well, we're going to have to move the 5 out of the way and the negative 2 out of the way. You always go after the thing that's added or subtracted first. You learned how to add or subtract first in your life, so let's take care of that first. So plus 2 on this side, plus 2 on that side. Be careful here. Grab this one that you've moved over, 2, plus or minus 2. So we're going to take what we've moved and write him first, and then what was there. behind it. Still trying to get x by itself, we're going to have to divide both sides by 5. So we get 2 plus or minus 2 divided by 5. All of those are like terms. So you are required to not stop at this point. You have to continue and break them up. 2 plus 2 divided by 5 and 2 minus 2 divided by 5. So we get 4/5 and we get 0, and there are 2 answers. Those are the only 2 answers in the whole wide world that are going to make this a true statement. So it makes them kind of special. Okay, let's finish this section up. We're going to have a round-robin tournament, round-robin game, round-robin tournament, whatever. That means that everyone is paired with every other player. The function, this function, models the number of chess games, n. The number of chess games in our formula will be n. And I'll explain this. That must be played with T players. Okay, let's look at the formula first. N equals T squared minus T over 2. Okay, we have 2 variables here, so let's figure out what each variable means. The N is the number, N, starts with an N, the number of chess games that are going to need to be played with T players. So T stands for the number of players. So if we have 8 players, that's going to be a certain number of games that are going to be required for everybody to play with everybody else. If we have 3 people playing, that's a different number. It's a different N for all those people. All those 3 people get to play with each other. So what you're going to be told here, you have to be given every single problem we have. If it has 2 variables, you have to be told what one of them is. Otherwise, we can't do it. So in this particular problem, they're going to tell you 15 games were played. And they're going to ask you how many players were there. Okay, I know my scribbling is not the neatest in the whole wide world. 15 games were played. How many players were there? So your job, your first thing you're going to have to do at this point is decide if 15 goes in the T place or the N place. So go back and look. We know games were played, games. So the number of chess games is N. So we're going to put a 15 in for N. And then that leaves T that we're going to figure out. And that we know that T is players, and they're asking us how many players. So that matches. That's good news. That matches. We want our missing thing to be their missing thing. So if we were told 15 games were played, let's put a 15 in there. 15 equals T squared minus T over 2. We'll be able to solve this to come up with how many players there were in this tournament. Okay, so let's look at what we got. I see T squared. I know that that means it's a quadratic equation. That means I'm going to have to do zero factor property to figure this out. So what I need is these guys to be on the ground. They've got a denominator. Let's get rid of that. So the way to get rid of divided by 2 is to multiply by 2. 1 in the numerator, 1 in the denominator cancels, and we've got T squared minus T on that side. Cool, that's what we want. If we multiplied that side times 2, we got to multiply both sides times 2. So we get 30 equals T squared minus T. Great, now everybody's on the ground. That's a huge step toward getting this problem solved. Next thing we need to do here is do what we always do. What we always do with these things is get a 0 over here. So let's move the 30 over here. See how t squared is positive where he is? So leave him there. We don't want to move him over here and end up with a negative on the highest exponent. You always want the highest exponent to be positive. So let's move 30 over here. He'll become minus 30. So we get 0 equals t squared minus t minus 30. If it bugs you that 0 is over here, there. Takes care of that. No big deal. Okay, so we have a quadratic that we need to solve. Let's assume we can do this, 0 factor property. And I can promise you we can do it 0 factor property, because look at what we're trying to find. How many players were there? That's a rational number. How many players, how many people? That's a rational number. So whenever you know it's going to be rational answers, you can always just factor it the way you're more comfortable with. So let's put some t's here. Let's look what we got here. We got a minus sign back there, so you know the signs in your answer are going to be different. Now we need two numbers that multiply to give us 30, whose difference is, you know, there's a 1 there, whose difference is 1. So we need next door neighbor numbers. We'll use 5 and 6. Okay, 6 is the larger of the two numbers, so we want to pair 6 with the first sign in this problem. The first sign in this problem is a negative, so pair the 6 with that. Put the 6 back here and the 5 there, and just like with Wednesday, if these two sets of parentheses have gotten up and changed places with each other, no problem. This is the only arrangement that you can use to get a negative 1t there in the middle term. The outside now is a negative 6t. The inside is a positive 5t. That gives you that negative 1t. Oh, Ashish, are you back with us now? Are you unfrozen? Or can you even hear me? Okay, good, cool. Okay. That's just going to happen. That is going to happen. Yes, I will do that, Chloe, just a sec. And I see Adrian's having some problems right now. It's just going to happen during the semester. If you're so lost on a problem, you can go into the recordings later and look. We'll figure it out. This is part of your struggle with this semester. Okay, so the numbers that you pick, Chloe, that's what you're asking. How did I decide on 5 and 6?
I'll just turn my microphone on so you can hear me. But no, like the -6, or plus +5.
Okay, who goes where?
Right. Just you said something like if the larger number is something.
Okay, always when you figure out your pair of numbers, always grab the big one. So I know I'm going to take the big one and I am going to pair him with whatever was the first sign, the sign right after the t squared or the x squared or the y squared. So that's a minus right there. So that's why I put the 6 next to the minus sign. Because I want the negative sign to win. I want it to be a negative there. So I'm going to put my big guy there. Send your big guy to the battle to put the negative there. You're welcome. And every single time we have one of those, I will go through that idea. So we're always going to put the big guy on the first sign. If that had been a plus sign right there, we would have put 6 over here with the plus sign. And keep asking, Chloe and anybody else, keep asking when you get stuck on something like that. I want to, like I said to you last Wednesday, my job is not to teach. My job is to make sure you learn, and those are completely different things. Maybe not completely. Okay, let's keep going. So set these up. T plus 5 equals 0. T minus 6 equals 0. T equals 6. Well, that's a normal answer. 6 people could have played, but we got this other answer. Oh, that doesn't make any sense, that -5 players were playing chess. So this is a garbage answer. And here's our answer. So if 15 games were played, that must mean there were 6 players. Okay, so what that means is that there was 1 chess match, 2, 3, 4, 5. And then this guy's already played him, so 6, 7, 8, 9. This guy's already played both of those, 10, 11, 12. This guy's played everybody but him, 13 and 14, and I missed something up, but it'll get to 15. I made too much of a mess there, too much of a scribble mess. But there would be 15 matches played. That's what we've just found out. Okay, ladies and gentlemen, we are done with 1.5. Let's go to 1.6 and see what we can do with a section called Other Types of Equations. Other types of equations. And they're going to be very much like what we've done, very much like what we've done. Let's look at our two types, or actually, let's look at a couple of definitions. You need the definition for radical equation. A radical equation is an equation with square root, cube root, fourth root, etc. You're going to have that as like #1 problem on my math lab. You'll never have it on a test, but it is, one of the questions. The second question on my math lab asks you about extraneous solutions. Extraneous, extra, and then N-E-O-U-S. Extraneous solutions. Those are solutions of a squared equation that aren't solutions of the original equation. Extraneous solutions are solutions of a squared equation that aren't solutions of the original equation. Let's wait on explaining that until we have one. It won't take, we may not get to it today, but I will come back to you and explain what that means, what that gobble, probably each individual word you could handle, but all together you might not know exactly what they're talking about. I'll explain that to you Wednesday if we don't get to it today. Okay, first thing you got to do on these problems, let me give you a problem. Yes.
Can you re-say what that second part of extraneous solution is? I can't really read it very well.
Yes, ma'am, I will do that. Solutions of a squared equation that aren't solutions of the original equation.
Thank you.
Cool. You're welcome. Let me go over that one more time for anybody. Solutions of a squared equation. So we're going to be squaring some equations. We'll get there. Solutions of a squared equation that are not solutions of the original equation. And again, hold off on that. I will come back to that and explain how it affects our lives. Let's look at the square root of 2x plus 4 equals x minus 1. Now, in my math lab, they are not going to ask you to jump in and do everything on this problem. What they're going to ask you to do is, when you square this side, what do you get? They're going to ask you to square that side. So let's do that. That'll be their first question. If we square this side, that's squaring it and unsquaring it. Oh, we've done that before where we put the radical on, remember? But squaring and unsquaring, they cancel each other out. So when you square the left-hand side, you're going to get 2x plus 4. That's the answer to one of the problems you'll have in my math lab. They'll ask you only, what do you get when you square the left-hand side? Well, when you square this, squaring and unsquaring cancel each other out, and poof, you got a 2x plus 4. In that same problem, they're going to ask you to square the right-hand side. They're going to ask you what you get when you square the right-hand side. When you square x minus 1, that's saying x minus 1 times x minus 1, and poof, you've got a foiling problem that you've got to take care of. So let's FOIL this out. X times x is x squared. The outside is a negative x, or a negative 1x if you prefer. The inside is the same thing, a negative 1x. And the last, negative 1 times negative 1 gives you a plus 1. You have to combine those like terms. So I owe you 1x, and I owe you another x. I owe you 2 x's. And there's the second answer. So in a problem, like this is number 1 right here, this is number 2 right here, this would be number 3. They're going to ask you what happens when you square the left-hand side. Squaring and unsquaring cancel each other up. You free up 2x plus 4. The next part of number 3 will be square the right-hand side. And that's a FOIL problem, and there's the answer to that part. Okay, let's do just baby steps on a couple more problems. You're going to have a problem like x to the 2/3 equals 4. And they want a baby step from you here. So let's look at the baby step that they want. They want you to be able to figure out, what do you have to do to the left-hand side to get x equals on its own? You want to turn that exponent 2/3 into a 1. You want x to the first. You want to end up with x equals here. So what do you do to 2/3 to make him become a 1 is what they're asking you. What you do with an exponent to make him become a 1 is to raise him to his reciprocal. So 2/3, the reciprocal of that is 3/2. And why that works, let's take just that piece off to the side. 2/3 times 3/2. The 3 on top cancels with the 3 on bottom. The 2 on top cancels with the 2 on bottom, and you get a 1, which is exactly what we want here. X equals is the same thing as x to the first equals. So what you want to do is you want to raise 2/3 to the 3/2. And we will do this a bunch, and we will do this a bunch. So you'll get really used to raising an exponent to his reciprocal. You went way too far on that, Kaylina. We're not going to go that far on this particular problem, but we will get there eventually. So what we want to do here, the only thing they're going to ask you to do is do the same thing to the right-hand side. So your brain has to say, okay, I got to raise this exponent to 3/2. Whatever I do to the left side, I've got to do to the right side. And that's all they want right now. They want 4 to the 3/2 as your answer. That's all we're going to do on this first one. We will explore some more on Wednesday, but not right now. Okay. This is one type of problem that we're going to look at. Let's see. In other types of equations, we're going to look at some like this where we have to square both sides. We're going to look at that in a little bit. On some of them, we're going to look at where we have to figure out what exponent we have to put there, and we're going to match it over here. The third kind of other type of equation we're doing in this section is funky ones. They're called quadratic, I call them quadratic wannabes. What do they call them in the book? Equations similar to quadratic, or they're quadratic wannabes. Let me show you. If we've got x to the 4th plus 8x squared plus 15 equals 0. If you kind of cross your eyes a little bit, that sort of looks like x squared, an x, and a number, which we've been working with extensively so far in this class. But it's like quadratic, equations that are like quadratic. What we're going to do is we're going to turn these suckers into x squared x and a number. We're going to do that. The way to do that is to take this piece and make him be an x. So every single time we do these problems, I'm going to say, let a new variable, I need a new variable for myself. And trust me on this, I don't want to explain it to you why we're using a funky little variable right now, because it won't make sense to you. But once we get into the problems, it will make sense to you. So I'm going to create this little thing called mu. It looks like a U. It's really an M. You can see how it's kind of a cute little M, a stylized M. It's a Greek letter. This symbol means it's pronounced mu, like a cow with a speech impediment. Mu, like that. So it's pronounced mu, long U there. That's the Greek letter. And I want to make that equal to x squared. So I'm going to take this little guy and make him equal to mu. What that is going to do, that is going to create this being something new. Let me show you what it's going to create. Let's put a 0 at the back. Let's do an equal sign next. And I'm starting at the back because it's the easy stuff at the back. 15 goes next. Then a plus sign. Then, oh, look, this x squared. Well, I'm calling this x squared a mu. So let me put a mu right there. My new little variable. It's this variable you've never used before, and I want it to look weird to you. I don't want you to use x or y or r. I want you to use something that's going to snap your head back and say, oh, this is a weird problem. I need to do something different here. Then we have an 8. Then we have a plus sign. And then you have x squared, this guy, squared. So put a mu squared there. This will always be a mu squared for us. You'll never have to worry about that. So if you follow that concept that this x to the 4th is x squared squared, so we got to square this guy, great. If not, just play the game, put the mu squared there. Now we have a problem we can factor, and it's just a normal quadratic problem. This is a quadratic wannabe. This we have turned into a quadratic. Okay, that's not complete. We're not done with this. What I want to do right now is practice this baby step one more time. They're going to give you baby step practices too. Let's start a new problem. X to the 2/3 plus 5x to the 1/3 plus 6 equals 0. Okay, again, if you kind of cross your eyes a little bit, this sort of looks like a quadratic problem, x squared, x, and a number equals 0, but it's not. It's a quadratic wannabe, and we're forced to turn it into a quadratic problem so we can solve it. And we'll be doing that on Wednesday. This is just a little baby intro to it. So we need to come up like we did here. Let's let mu equal, and remember we're going to take this piece that sits behind b, x squared, sits behind b, x to the 1/3. That's going to be what we're going to substitute mu for. Okay, now let's go substitute mu in here. Start at the back, 0, then an equal sign, then a 6, then a plus sign. Oh, there's an x to the 3rd. X raised to the 3rd power. X to the 1/3 power, we're calling mu. Then a 5. Then a plus sign. And then this is the square of this. We've taken our little piece here and squared it to get to here. So if we want to substitute in a mu, let's square this. Mu squared right there. It is weird, Tyler. It is weird. But it's so incredibly useful. And you'll see how useful it is on Wednesday when we do actual problems with them. We're going to do, I'm seeing 3 here, at least, yeah, 3 good ones like these, where we'll take this and factor it and then plug it back in here. It will be, it's kind of a cool deal, but it's really important to me that, good. it's really important to me that between now and Wednesday, you go into my math lab and prepare yourself for the work that we're going to do. Prepare yourself by doing this baby step right here. Prepare yourself by doing that baby step. Prepare yourself by doing this baby step twice. Okay. What time are we looking at? 4 minutes. Yeah, let's do one more. That, you know what? No, let's not. So what I want you to do, less than 4 what, Tyler? Oh, 4 minutes. Yes, sir. Thank you. Yeah, thank you. So what you've got to do tonight, or before Wednesday anyway, is you need to go look at Ms. Campbell's video. That's on my bottom slide. It's 3 minutes. You can handle that. You need to set up Proctorio on this site, on this Blackboard site. That is the middle instruction where you got to get Google Chrome and then you click into Proctorio and it gives you good instructions. And then go ahead and finish 1.5 and do 1.6 until they've done this last practice quadratic wannabe problem. So you'll have 2 of those quadratic wannabe problems. I don't know when you'll hear about that, Tyler. I will contact Rebecca and give her your phone number and ask her to add you in, and then I'll let you know. But I will not forget. I got your number sitting right here. Yeah, it'll be soon because she'll be in the 2 o'clock class. I'll even email her and see if she's around. Okay, so those are your jobs for between now and Wednesday. I need you to understand this at this level for Wednesday so that you can solve them on Wednesday. Okay, open your mic and tell me what your problem is if you got problems right now. Anybody, anything? Charles.
So when you were subtracting the u for the last one, how did you get 5? Because when you circled the x 1/3, did you just not add the x over 1/3, or did you just take the 5?
Well, instead of this x to the 1/3, we're saying whenever we see x to the 1/3, we're going to put a mu. So there's no adding or subtracting going on. I'm just I'm plucking this out and putting a mu in his place.
So how did you get number 5 though? So you're pretty much getting rid of the x and just putting the 5 in front without putting the 1/3?
Instead of that piece, I'm putting the mu. So I'm taking this completely out and putting in a mu there. And so it's 5 mu. Same thing here. Instead of this x squared, I'm putting a mu. So I'm taking that completely out. And now I have 8 mu here.
So in a way, you're just canceling out the previous equation and just keeping the number 5 in front of the u.
Yes.
Okay.
I'm substituting. I'm plucking out that x to the 1/3 and putting in the mu. So the 5 didn't go anywhere. He's still just sitting there looking around, wondering what's happening to his buddy, his next door neighbor.
Okay,
Is that
I
okay?
get it now.
Yeah.
So
We'll do it some more. We'll do it on Wednesday. It'll be what we do at the end of 1.6 on Wednesday. We'll get there. Hey, Lena, do you have a question?
So do you always substitute the mu with the middle term of the problem?
Always. Yes.
Okay.
Always. Anybody else, anything? Thank you, Chloe. Yeah, I'm done if you guys are done. I'll stick around. And in fact, if you haven't had your little 15-minute chat with me, Luce, can you stick around? I had talked to you about doing that. Can you stick around and we chat for 10, 15 minutes? Great. Okay, so you stick around. Everybody else, go on about your life. Enjoy your life. I'm going to stop recording this first.